Hello students, in this session we will discuss about the remaining operations of a double linked list like insertion and deletion operations. First one, how to insert a node into the double linked list. Now as similar to single linked list insertion operation, here also the insertion process falls into three cases like front insertion, rear insertion and any position insertion. First case, front insertion. In this case, a new node is inserted at the front position of the double linked list. Next algorithm procedure. Now algorithm F insertion of X. This procedure inserts an element X at the front end of the list. For this, step 1, allocate memory for a new node. So with this allocation, three parts are available. Now data of new is filled with X, link of new is filled with null pointer, link of new is filled with null pointer. Step 2. Now first we check whether previously any elements are available or not. So if start equivalent to null, that means elements are not available, then start equivalent to end equivalent to new. Else if elements are available, now link of new is filled with start, link of start is filled with new. Then start variable shifted to new location, and if. Step 3, return. Now observe this example. Now this one is initial status of the list. So here three elements are available, 59, 24 and 64. So when we apply front insertion operation, so node is inserted before the start node. Now the list becomes 26, 59, 24 and 64. Next operation, rear insertion. In this case, a new node is inserted at rear position of the double linked list. Now algorithm process. Algorithm or insertion of X. This procedure inserts an element X at the rear end of the list. Step 1. Allocate memory for a new node. Data of new equivalent to X. Link of new equivalent to null. Link of new equivalent to null. Step 2. If end equivalent to null, then start equivalent to end equivalent to new. Else. Now we establish links in between end node and new node like link of end equivalent to new, link of new equivalent to end equivalent to new. Your comparison part completed, and if. Step 3, return. This example. Now this one initial status of the list. Here the elements are 59, 24 and 64. Now when we apply R insertion of 26, now this new element is inserted at rear end of the list. Hence the list becomes 59, 24, 64 and 26. Now case 3, any position insertion. So in this case, a new node is inserted at a specified position of the double linked list. Now algorithm any insertion of, here we pass two arguments x comma pos. This procedure inserts an element x at the specified position POS of the list. For this, first allocate memory for a new node. Now data of new equivalent to X, link of new equivalent to null, link of new equivalent to null. Now step 2, to reach the control at the specified position. Now first k is initialized with 1 and a temporary variable ptr that points to start node. Now apply some repetition process like repeat while k less than POS. Now we set another temporary variable that points to ptr. Now ptr shifted to link of ptr location. Now k is incremented by 1. The repetition process completed and repeat. Now step 4. Now we establish links in between temporary node, new and ptr like link of temp equivalent to new, link of new is filled with temp, link of new is filled with ptr, link of ptr is filled with new. Step 5. Return from the function. Now observe this example. So this one initial status of the list 59, 24 and 64. Now when we apply any insertion of 26, 3, so we are inserting a new element 26 at third position of the list. Now the list becomes 59, 24, 26, 64. So these are 3 cases to implement insertion operation. This one, deletion of a node from the list. So it refers to deletion operation. So deletion of a node also falls into 3 cases like front deletion, rear deletion and any position deletion. First operation, front deletion. So in this case, the front node information is deleted from the double linked list. Now algorithm process. So algorithm F deletion. This function removes the front element of the list. So here, step 1, first we check whether elements are available or not. So if start equivalent to null, that means elements are not available, hence return -1. Else, if elements are available, first access the data part of start node. So k equivalent to data of start. So if start equivalent to end, that means only one element is available, then start and end are set at null pointer. Else, if it consists more than one element. Now temp equivalent to start. Now we break the links in between temp and start nodes. Hence start is shifted to link of start. Now link of start is filled with null pointer. Link of temp is filled with null pointer. Now release memory of temp. End if. Now return k. And if. Outer comparison completed. Now observe this example. So this one initial status of the list. Here 4 elements are available like 59, 24, 26 and 64. Now we are applying F deletion operation. With this, the front element is deleted from the list. Hence front deleted element equivalent to 59. So after deletion, now the list becomes 24, 26 and 64. So this operation refers to front deletion operation. Second one, rear deletion. In this case, rear node information is deleted from the double linked list. Now algorithm or deletion. This function removes the rear element of the list. How the process? If end equivalent to null, then return -1. Else, now k equivalent to data part of end. If start equivalent to end, then start equivalent to and equivalent to null, else. Now ptr equivalent to end is shifted to link of end. Now rlink of end is filled with null point. Now release memory of ptr, and if return k and if. Okay. Now this one example. This one initial status of the list. Here the elements are 59, 24, 26 and 64. Now we are applying or deletion operation. That means we are deleting rear element of the list. Here rear element is 64, hence rear deleted element equivalent to 64. So after deleting rear side element, now the list becomes 59, 24 and 26. Now case 3, any position deletion. So in this case, a specified position element is deleted from the double linked list. Now algorithm, any deletion of POS. This function removes the specified position POS element of the list. Now step 1. If start equivalent to null, then return -1. Yes. Now ptr equivalent to start, p equivalent to 1. Now it's a repetition process. Repeat while p less than POS, temp equivalent to ptr. Now ptr equivalent to rlink of ptr. Now p equivalent to p plus 1 and repeat. Now access the data part of ptr as k equivalent to data of ptr. Now we break the links like rlink of temp equivalent to rlink of ptr, link of rlink of ptr equivalent to link of ptr, link of ptr equivalent to null, rlink of ptr equivalent to null. Now release memory of ptr. Return k. Now comparison part completed and if. Now observe this example. Here the list consists 4 elements like 59, 24, 26 and 64. Now we are applying any deletion of 3. That means we are interested to delete third element of the list. Hence deleted element equivalent to 26. Now the list becomes 59, 24 and 64. Okay. So this one deletion operation. Now finally we go for disadvantages of a double linked list. Now advantage point of view, in double linked list we can traverse in forward direction as well as in backward direction, so that it overcomes the disadvantage of single linked list. But there is a small disadvantage in double linked list. Here we can traverse either from the starting node or ending node, but traversing from a specific location is not possible. To overcome this, we go for another type of linked list like circular linked list. Okay? Thank you one and all.